Hi everyone, welcome back to Code Y, and this is another question in the Hackerrank series. Um, this is one of the questions when I started out. I remember this question. I saw this as one of my first few coding practices question, and I was so stumped by it because I was beginning with the whole competitive programming or just trying to learn how to do this thing. And this is one of the first few questions, and I was so kind of demoralized. But there is a trick to this question, and this trick can be applied to many different questions as well. And yeah, it's a useful trick, and I hope to cover this today. And yeah, I'll just go through the question and get straight into coding it. As usual, I'll try to do this as fast as possible and keep my explanation as succinct as possible. So let's jump into it. So yep, this is there's some story over here. Um, Basically, there are like a bunch of people over here. Like each person, just think of them as the names start from one all the way to whatever number that whatever is the length of the whole array. So in this case, it's 1 to 8, but they are allowed to bribe each other. So someone from the back, so 8 can bribe 7 and go in front. Like they just swap places, like a bubble sort kind of a solution. So in this case, they can, if they bribe more than twice, we consider this too chaotic. So yeah, any one person can bribe at most two others and determine the minimum number of bribes that took place in order to get the given queue order. Print the number of bribes, or if anyone has bribed more than two people, print chaotic. So yeah, we just need to find out how many bribes has taken place for this sequence to be there. So in this sequence, it's 1, 2, 3, 5, 4, 6, 7, 8. Most of it is in order except for these two. It's just we just need to swap these two and then we get the order that we want. So it's just one bribe that is required. In this case, 4 was all the way at the back. So 4 had to like bribe 3, 2, and 1, which is more than 2 bribes. Hence, we just print 2 chaotic. We don't even need to analyze it any further. So the first trick in this question is find the early termination condition. Like if we know that we can terminate the whole program at some point, like we don't need to run through every single combination. We don't need to go through all of it to see if anything has more than 2. Once we see the more than 2 condition, we just immediately end the program and print out 2 chaotic. So that's the first trick in this question, but that's not the challenging part of this. So that's one. So let's just scroll down. They were kind enough to give us like some pictorial examples. So in this example, which is 2, 1, 5, 3, 4, 1 and 2 have been swapped once, and then 5 and 3 are swapped once, and 5 and 4 are swapped once. So effectively, it is 1, 2, 3, 4, 5. So in order to get from this to this, we need to swap 3 times. Now, there are many different ways to approach this, but the approach that I like the best, that I like the most, is to check from the back. And what do I mean by that? Like, let's say if I have an array of 5 items, that means I know the last item should be 5. So I go to the last element and I search if 5 is there. This is not 5, I go to the next one. This is not 5, I go to the next one. Once I've seen 5, I will pop this out. I'll just delete this, and the remaining program would be, let me get my marker. The remaining array would be 2, 1, 4, 5. Sorry, no, what am I doing? If I pop 5, the remaining program would be 2, 1, 3, 4. Next, I continue the sequence again. The next item should be 4. I go here. I have reached 4, so I pop this. The next item should be 3, and I reach 3. I pop 3. The remaining item that I'm looking at is 2, 1. I'm looking for 2. This is not 2. I go to the next one, so I bribe one more time, and I reach this. I found 2. I pop it. And the last one, I'm looking for 1. I go to 1, and I found it, and I pop it. And effectively, I have bribed once, twice, and thrice. And we know that three bribes are taken, and we have the 3 over here. So that is the approach that I'm recommending you guys. The reason why this works is because a person can take a bribe unlimited number of times, but a person can only give a bribe 2 times. Okay, so let's process that a bit first. If we can give as many times as possible, give only twice, we should just focus on that and not focus on the how many times someone might have received it. So I'm going here, I'm searching for 5, and 5 can only be within two, can only be like in front of itself by 2 places. It cannot be like 5 places in front. If it is 5 places, 5 indexes in front of itself, that means something wrong has gone down. But a 1 might end up being in the last position because the rest of the elements decided to bribe in front. So in that case, that's why we're going from the back. We are seeing which element, how far away is the item from its original place from the back. So that is the pseudo code kind of way, like explaining how I'm going to code it out. Coding it out is a bit more, it's a bit messier. So let's hope I get it in the first try. I'm just going to try to type it out, type out what I'm, type out my code. So first things first, I'm going to have a variable called bribe, which this will be the one that I'm returning at the final last stage. The next thing is I'm having a certain kind of like a way to check if the whole thing is empty. What do I mean by that? Like I'm popping at every single instance, right? Like I'm popping it, I'm popping this, I'm popping that. So I can try to use a while loop so that I know that I've run through all the items before getting in. So I can do something like this. While len q equal sign 0, sorry, not equal sign 0. I keep running a program. So um before that, I need to know what is the last index. So last index and last item is equal to len q is the last index minus 1, while last item would be, the last item would be the length of q itself. Like what is the original item that is in the last place? That would be length q. Like if the whole array's length is 5, the last item is 5. Okay, so that's what I mean. So while length of q is 0, is not 0, what I'm going to do is I'm going to check if the last, I'm going to check from the last item. So I need to do a for loop that will run in reverse. For I in range, to be honest, I can just do like I can limit it to just observing these 3. That means if the item that I'm looking for is not in the last 3 items, I terminate the program early. I can do something like that. Maybe I'll do that. Yep. For I in range, so the last, so I'm going from this, the last place, to this place. So the last place would be len q minus 1 all the way to len q minus 1 is here, len q minus 2 is here, len q minus 3. Okay, let's just go minus 4. Actually, wait. Yeah, you need to go one more than, yep. So len q minus 1 all the way to this spot. And I need to put a minus 1 because I'm going in reverse order. So yep. To be honest, this doesn't matter. I could have just done the full range because I will be terminating it if it reaches beyond this point. If it traverses beyond this, I'm going to terminate it. I'm going to just put a break in the for loop. So for I in something something, so for if this item, so the item in focus, if qi equal sign last item, that means the item that we are looking for. That means if this item 4 is equal to 5 as it is supposed to be, I will okay, first thing, count has got to be 0. I'll mention what count means in a while. So count is basically the number of bribes that I'm giving. So initially, if I go here and I immediately see it as it is, like five, I'm searching for 5, and the first item that I see is 5, I don't need to take a bribe. Like I didn't give any bribe. I didn't. So bribe, I'll just plus equals count. It, like since it's 0, it'll just be 0 at this point. It'll make sense in a bit, but else, that means if the last item is not, that means I'm looking for a 5, but I got a 4. What I need to do is I need to go to the next item. So count increases by 1. And yep, count increases by 1. And there should be elif here. Elif count is equal to 2. That means if count is already equal to 2, we can just return to chaotic. Else count is plus 1. So let's run through this sequence again. While the length of queue is this thing, if the item that we find is the same as this, that means if I'm looking for a 5 and I find a 5, I add it to the bribe, whatever the bribes I've given, I just add it into the bribe. And the next thing that I do is bribe, sorry, q dot pop I, because I need to pop the element over here. Like let's say let's just do this example now. The example that I said, whereby I'm going for the first item. So the last item is 5. The last index is 4. To be honest, I don't need the last index, right? Do I need a last index? I don't need a last index. Okay, never mind. Doesn't matter. Let's optimize things later on. So for I in range, this thing, if I is equal to last item, is I equal to last item? No, it's not. Qi is 4, while I'm looking for a 5. So I go here. Is count equal to 2? No, it's not. So I go here. Count is plus 1. So count becomes 1. Count becomes 1. So after count becomes 1, I'm going into this. I'm going to the next item, which is this index. Qi is now 3. It's not a 5. So I skip this, and I go here. Count becomes 2. Now I need to go here. Now this is 5. This is 5. Qi is 5. Last item is 5. So I need to add bribe. Bribe becomes 2. And with that, I need to pop this now. I need to pop this out. So yep, that is this. So now that all of this is done, I clear all my drawings. Okay. We are good to go to the next stage. That means I can go back into the while loop. Since I popped it already, I've popped it so I can return it. But before I return it, I need to make sure that the last item that I'm looking for right now changes as well. So okay, I think I need to make a small edit over here. I don't need the last index item. I don't need this. I just need this. So after I run the for loop, I just update it because now the last item that I'm looking for is this. After I run the for loop and I'm happy with everything. I popped everything out already as I wanted to. I can break the program early. I can just break it early. So the for loop will be broken, and then I'll go here. The last item is equal to len q. That means I'm resetting. The last item is previously was 5. After popping it, there'll be 4 items. Now the last item will be 4. So we will continue in this sequence. And once I'm done with this whole thing and I didn't early terminate at any point into the return chaotic, I can just return bribe. And with that, we're actually done. We are done with most of the code. But one more thing to take note is this thing. We need to print out print Q. We need to print this out. Sorry, what am I saying? I'm returning a value to the minimum bribes because I don't want to print it at any point. I want to use the return function to early terminate. So minimum bribes should return a value, and that value be assigned to the val, and I'll just be printing the val. So this is a boilerplate code that they have provided in Hackerrank. A lot of times they'll just provide this because it's a waste of time for us to figure this out. Yeah, so now val would just be either too chaotic or bribe. So let's run the program and see if it works. So yeah, it works. It passes the test case conditions. Let me submit it. And wonderful, it passes all the test cases. Take some time to go through the sequence slowly. The two tricks that I recommend over here is find the early terminating condition. And next up, pop is a very time complexity saving thing, because right now by doing q.pop, pop by default would take the last item away. By putting an index to it, it'll just find the specific index and pop it. In this case, this is not too time complex because we are taking it from the last end, from the back, from the later part of the array. But if it was taking from the front part of the array, it would be very time consuming. Right now, it's only in the, it's either index 1, 2, or 3, like this index, or this index, which is only a scale of 3, which is not too time complex. But if it was in the front, and if we had like a really huge array like the ones that they mentioned over here of this magnitude, it would just crush our program. So we cannot use this in those cases. But for most cases, this would be really helpful. And yep, hope you guys enjoyed the video, and I will see you guys in the next one. Do leave a comment to suggest if there is any way that I could improve this code, or if there's something that I oversaw, any redundancy in my code. Happy to explain or understand and learn for myself. So yeah, thank you so much, and I'll see you guys in the next video. Bye.